Now, the table of the transformation matrices, we don't actually have to memorize it. There's actually kind of an easy way to do it. And all we have to do is we have to look at the 2 points represented by the matrix, actually by the points 1, 0 and the point 0, 0, 1. Okay, and all we need to do is figure out what the transformation does to that point, and that will give us the columns, the new points, which are the columns of our transformation matrix. So for example, for dilation by a factor of k, if I just look at the point 1, 0, and I dilate that by a factor of k, that ends up over at the point k0. Okay, so this tells me that my first column is going to be k0 for the transformation matrix. Okay, at the point 0, 1, okay, if I dilate that by a factor of k, that ends up at the point 0k, which means that that's my second column, 0k. And this pattern works for each one. I'm going to go through each one so you can kind of see that. For reflection in the y-axis, so we're going to look at the point 1, 0, and if I reflect that in the y-axis, that jumps up over here, and we'll end up at negative 1, 0. That means that my first column is negative 1, 0. Okay. The point 0, 1, if I reflect that in the y-axis, it doesn't actually change. It just stays where it is at 0, 1. So my second column is 0, 1. So that's the transformation matrix for reflection in the y-axis. For reflection in the x-axis, if I look at the point 1, 0, it doesn't actually move anywhere if I reflect that in the x-axis, since it's already on the x-axis. Okay, so my first column is still 1, 0. The point 0, 1, okay, if I reflect that in the x-axis, that jumps down here to 0, negative 1. And so that's my second column of the transformation matrix. For a reflection in the line y equals x, if I look at the point 1, 0, and I reflect that, here's the line y equals x. Okay, if I reflect that in the line y equals x, it ends up here at the point 0, 1. So that's my second column. Okay. The point 0, 1, if I reflect that over the line y equals x, sends me to the point 1, 0. So that's my second column. For reflection in the line y equals negative x. So the point 1, 0, oh, sorry, this is line y equals x. Y equals negative x is that line right there. If I take 1, 0 and reflect it, it ends up down here at 0, negative 1. But at the point 1, 0, that reflects over the point negative 1, 0. Okay. For rotations, okay, this process works for all of them. For a rotation 90 degrees clockwise, if I look at the point 1, 0 and go 90 degrees clockwise, that takes me to the point 0, negative 1. I look at the point 0, 1 and rotate that clockwise, that ends up at the point 1, 0. If I do a 90-degree counterclockwise rotation, the point 1, 0 ends up here at 0, 1. So that's my first column. If I take the point 0, 1 and rotate it, I get the point negative 1, 0. That's my second column. And finally, the rotation of 180 degrees around the origin, or reflection in the origin, they're the same thing. Okay. Well, the point 1, 0, if I rotate that 180 degrees, it ends up at negative 1, 0. If I take the point 0, 1 and rotate that 180 degrees, that ends up at 0, negative 1. So that's an easy way to find the transformation matrix for each of these things. Instead of having to memorize them all, you can figure out what they are. The key is to remember the point 1, 0. In other words, that's kind of the column we're starting with, and 0, 1. So this is kind of the starting point, and then you figure out what happens to each of those columns to get your new columns for your transformation matrix.